So in this slide, we are going to learn more about the introduction. So I give this link. You can go back to the previous chapter, or you can go to the next section. Okay. So in this Jupyter notebook, I would like to mention about how we deal with the installation. Okay. So we need to understand how to install if we have a kind of library. And then I would like to discuss about Numpy. So in this section, it will be about Numpy. And the other notebook will be related to pandas. So what is the installation? First, data science implementation requires several external libraries. So the Anaconda itself, it has only the basic platform or the basic libraries. But people try to make their own libraries, and they share the libraries. They share the libraries in GitHub. They share the libraries in the Python repository. Okay. In Anaconda tool has included some basic libraries. However, some other external libraries are necessary to be installed manually. So if you are using the Anaconda, you already have the Numpy and you already have the pandas. But I just want to teach you, if you want to include some other libraries, then you can go to the command prompt. Okay. Do you know what is command prompt? So if you are using the command prompt, means you can go to this Windows environment. So you can see the Anaconda prompt, okay? Or yeah, if you press CMD, yeah, there are two kind of prompt. You can use Anaconda prompt, or you can use this one, Myongryong prompt. Okay. So if you use this Anaconda prompt, then you will go to this environment. And in order to install something like, for example, you want to install pandas. Okay. So you can type pip, yeah, install, for example, pandas. So pandas is the name of the library. Okay. So I already have this one. So once you install Anaconda, you will have pandas. So you don't need to install the pandas again. Okay. But some other libraries are not in the Anaconda. So you need to install in your computer. If you want to install from the Jupyter notebook, okay, so if you want to use this Jupyter notebook to install your environment, then you need to put this one, not compute. Okay. So this exclamatory sign, you need to put before the comment. Okay. So let's say, this one. Okay, you can put exclamatory sign, not compute, and pip install pandas. Okay, and then you can press like shift enter. Yeah, it will install the library for you. Okay. Because I already have panda, so we get this message. Requirement already satisfied. Requirement already satisfied. Okay. But if you don't have the library, you can use this way. And also, you can install multiple libraries. Okay. So if we want to install only one library like pandas, then you can use pip install pandas. To do the data science, there are three basic libraries that are necessary for first-time programmer. So you need to install pandas, numpy, and matplotlib. Okay, so those libraries are the 3 basic libraries, and you can install it at the same time. So we can use the exclamatory sign, pip install, yeah, pandas, numpy, matplotlib at the same time. Okay, but in Anaconda, you already have those 3 libraries, so you don't need to install it. Okay, let's move on to the Numpy. Okay, what is Numpy? So Numpy, stands for numerical Python. Okay, that's why they call it num. Num is from numerical, py is from Python, Numpy. And it is one of the most useful scientific library in Python programming. It provides support for large multi-dimensional array objects. And it has various tools to work with them. Okay. When you learn about the computer programming, I guess you learn about array. Okay. So we already have the concept about lists in our previous lecture. Okay. In that lecture, we learned about the we learn about lists, tuple. Okay, and tuple is also a kind of array, but they are different. Okay. In lists, you can modify the element, but in tuple, you cannot modify. So it can have one or more dimension. What you learned before, it is only one dimension, but you can have multiple dimension, and yeah, we can say if it is 2 dimension, we call it matrix. Or you can have like 3 dimension, you can have 4 dimension, you can have 5 dimension. Yeah, it depends on how you define your dimension. Yeah. So in the array, if it is 1 dimension, we call it vector. If it is 2 dimension, usually we call it like matrix. If it is related with the numbers. Okay. And Numpy, people call it ND array. Okay. What does it mean by ND array? It is N means any number. Okay. D means dimensional. Array means, yeah, the arrays. So you can define any number of dimension for the array. So we will see the example later. It means we can store the elements of the same type and size. And Numpy, it is known as the high performance computation, and it provides efficient storage and data operation as arrays grow in size. So when the array is big, Numpy can compute in very good performance. So yeah, I already mentioned to you, if you have your Anaconda, I guess you have the Numpy. But if you just install Python, you need to install the Numpy separately. Okay. So let's discuss about Numpy, but I will just discuss very briefly about Numpy. I hope that you can have more ideas later. So first, you need to call. How to call the library? In order to call the library, you need to know what is the library name. In this case, the library name is Numpy. Okay. And Numpy, it consists of 1, 2, 3, 4, 5. So it consists of 5 letters. People, when you do the programming, okay, people will like to use very short syntax. If you can produce shorter commands or shorter statements, that will be good. So that's why when we use Python or this kind of data science, and if you use also Python for another purpose, we always try to import the library with S. So this S means alias. So we can import Numpy. So we want to use the function from the library Numpy, and later on, let's call it with NP. Okay, so NP means the shorter words for Numpy. Yeah, you can define this one. You want to use NP, you want to use NY, you want to use NU. Yes, that's fine. But I think people knows how to use Numpy with NP. So it's the most common short words. So you can import Numpy as NP. Okay. Press the Shift Enter. So once you have this cell executed, then you can run any Numpy. Okay. So for example, I would like to create an array. What is an array? Yeah, we know that it is a kind of list. Yeah. So if I have like this one, okay, np.array, and I have 1, 4, 2, 5, 3. So those are integer. Okay, I hope that you understand what is integer by now. In order to define this kind of array, you need to put inside the bracket. Okay. So there are two kind of bracket. Okay. This is the common bracket. And then inside the bracket, you need to use the square bracket. Okay. So this concept is the list. Okay. But the common bracket is only to represent the parameter of the function array. Okay. So you can just think that, okay, this is an array, a list of numbers, and we want to format it into the array of Numpy. Remember that unlike Python list, Numpy is constrained to arrays that all contain the same type. Can you understand? When you use list, okay, your data type, it can be anything. You can have integer, you can have float, you can have string. Okay, so you can mix. But when you use the Numpy array, the data type should be only one. If you use only integer, then all the elements should be integer. If you define the array is float, then all the elements should be float. Okay. If types that do not match, Numpy will upcast if possible. So for example, the integers are upcast to the floating point. Upcast, so you can go to the higher data type. So in this case, the floating point is higher data type. If you see this one, yeah, you can see that 3.14 is float. 4, 2, and 3, they are integer. So you need to make it in one data type. So the integer will be upcast. You can see here, now the data type is a float. This also a float, and this also a float. So the Numpy automatically changes the data type into float, even though you define this data as integer. If you want to explicitly set the data type, you can use the D type. D type means you want to set the data type of the array. Let's see this one. I have the array 1, 2, 3, 4, and I want to change this integer value to float. Okay. So I will explain a little bit later. The float has many kind of type. One of the type is float 32. Okay. So we have float 32, we have float 64. It depends on the size. Okay. So the bigger number means the bigger size. So you can see that the result is an array of a float number 1.0, 2.0, 3.0, and 4.0. So they do not print 0. But we know that this is a float because we have the point. And unlike the Python list, Numpy array can explicitly be multi-dimensional. So in Python, so I have not explained about the multi-dimension. Maybe hopefully a few weeks later, we will learn about the multi-dimension. But now let's discuss how we can define the multi-dimension on Numpy. Okay. And there's one way how to initialize the multi-dimensional array using a list of lists. Do you still remember when you have the comprehension list? Okay, so we have a list, and then inside the list we have a function or a repetition. In this case, if you still remember range, what is the meaning by range? Do you still remember what is the meaning by range? When you do with loop, okay, what does it mean by loop? It is iteration. Okay, if you put range 4, then you will do the repetition. Let's say for I in range 4, then you will start from 0, 1, 2, 3. Okay. The same with this one. I have the I comma I plus 3. So I can define like 1 comma 4, for example, like this one. It means I want to get the iteration from 1 and then go the next is 2 and then go next until 3 and stop. So I want to range from I, wait a moment, from I until I plus 3. Okay. And then the I will be in 2, 4, and 6. So I will do the array. The first is 2 because I start with 2. And then this array contain from I, which is 2. And then I will do until I plus 3. Okay. So I will do 2, 4, and 6. Okay. And then I will have 1, 2, and 3. So you know this one means I have like 0, 1, and 2. Okay. So if it is I equals to 0, okay, so the I will go to 2, 0, 1, 2. So I will print 3 elements. I will print 3 elements after the first number, which is I, which is 2. So this is the starting point, 2, and then plus 1, and then plus 1. And then next is 4, and then plus 1, and plus 1. And then this is 6, and then I will print 6, and then plus 1, and plus 1. Okay, so this is the meaning by this syntax. In this case, I have 3 rows, and every rows I have 3 elements. Yeah, we call this is multi-dimensional array. Or if it is a matrix, so we have 3 multiplied by 3 matrix. So the inner lists are treated as rows. Okay. So we call this is the inner list. We have the in row number 1, row number 2, and row number 3. So this is the data type that are available in Numpy. You don't need to memorize all, but at least you know that we can use the Boolean. Yeah, Boolean is true, false. Integer, integer is in the C we call it long. Okay, so in Java there is also the long data type. Okay? So it means it has a very huge number. Okay? Integer C, so it is based on the C programming language, just normal integer number. Okay? And so on. So you can see like this one, integer 8, yeah, it has the small size. Integer 16, it has bigger size. Integer 32, it has bigger size. Integer 64, it has bigger size. Okay? If you use int, it is only a positive integer, no negative. And u, yeah, it means unsigned. It means just the positive, positive. And then float, yeah, it has a number with decimal or with comma. So the higher number, it shows the bigger size. Okay? And also the complex, I think we will not use this complex. So if you need this one, yeah, you can try to use it one later. So we can create array from scratch. How we can create the array from scratch? I will give you 4 basic functions to create array from scratch. So we use 0, we use 1, we use a range, and we can use random number. Okay? And yeah, we will see more examples using the D type. First, if I want to create 0, so if I want to create 0 for 10 times, then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 zeros, and the data type is int, integer. So the 0 will be all integer type, and then later on you can modify. Okay. Once means you can define all the numbers as 1, and you can define the size. In this case, I define the size as 3, 5. So I have 3 rows and then 5 columns. And the type is float. So you can see here 1 point blank. So it means it is a float or it is a real number. Okay. We can use a range. Okay. So this a range is similar with range. Okay. So if you remember the iteration using range, the idea is the same with range, but it is a specific function in Numpy. So the a range means, yeah, I have 3 numbers, 0, 20, and 2. So the first number indicates the starting point. So I would like to start from 0. And then 20 is the ending or the last number. And 2 means the interval or the step. Okay. So, oh, I'm sorry, this is not create one. So we have the 0, and then because we have step by 2, then the next number will be 2. And the next number will be 4. The next number will be 6. The next number will be 8, 10, 12, 14, 16, 18, and yeah, stop. Because the ending is 20. And we know in range, it should be n minus 1. Okay. So it will not print 20. Now, if you want to create random numbers, okay, when you want to create random numbers, first you need to call the random function, so np.random, and you need to define what kind of random you want to use. Okay, so in this case, I just want to use any random between 0 and 1, and the number will be 3 rows and 3 columns. So this definition is only to define the size. And because we don't have any definition of this function, it is only the random with uniform distribution. We can use the random with normal distribution. I hope that you already have the understanding about statistics. Okay. If we are using the normal distribution, we need to define the mean and the standard deviation. And in this case, I would like to define that the mean is 0 and the standard deviation is 1. And I would like to make 3 rows and 3 columns. So this is the result. Okay. Because the mean is 0. Okay. So if I can draw it, the normal distribution is like this one. Okay. So this line indicate the mean. If it is 0 and the standard deviation is 1, so it can reach yeah, -1 until 1. Okay. Or it can be in that range. Okay. It can be more than -1, and it can be in the range of 1, or it can be in this one. But most of the numbers should be in here. Okay. So you can see that more numbers are in the in this area. Okay. We can make a random integer. So the integer number can be used for the random. And let's say I want to use the random integer. This is randint. And I would like to make a random integer between 0 until 10. So any number between 0 until 10. And I want to make the size 3, 3. So 3 rows and 3 columns. So this is the result. And remember, when we have 0, 10 means I will not print 10. So it is only a number between 0 until n minus 1. Okay. And in the Numpy, they have the same way to define the arithmetic. But it's because we are using factor. Okay. So the factor means the one dimension of the array. So the native arithmetic, we can use the addition, subtraction, multiplication, and division. Okay. So this is the basic operation in the arithmetic, and we can use it in array. Okay. So let's see. I have the np dot a range 4. Okay. And then I want to put this value into the variable x. So we have x, and the result of x is 0, 1, 2, 3. Okay, I guess you already know this one. This is the same with the iteration. Okay, range. Range also have the iteration with the same number 0, 1, 2, 3. And let's say I want to do with this kind of operation. What is x? X is an array. It is 0, 1, 2, 3. What if the result x plus 5? Then every number will be plus by 5. 0 plus 5, 5. 1 plus 5, 6. 2 plus 5, 7. 3 plus 5, 8. Okay. What about x minus 5? So every number will be minus by 5. 0 minus 5 is minus 5. 1 minus 5, minus 4. 2 minus 5, minus 3, and so on. What is the result if I have x multiplied by 2? Yeah, every element will be multiplied by 2. Okay. What is the result if I have x divided by 2? So every element will be divided by 2. What if I have the integer division? Yeah, every element will be divided, and we have the floor division. Okay. There's also a unary function for the negation, and we have the square and we have the modulus. Okay. So in this case, like you have the minus x, yeah. So you have the minus x. In this case, all the numbers will be in the negative. And then x squared 2. So every number will be power by 2. Okay. So exponent by 2. And I want to modulus remainder. So I want to get the remainder. So the x modulus 2, I will get the remaining values. This can be strung together. Of course, you can do with the multiple operators. And yeah, you already know which one is the first. Okay. So I will not teach you again about this one, but you can make a kind of function for this one. Okay. So in this case, yeah, you will do something in this bracket first. Yeah. And then after you have the results on the brackets, you will make it power of 2. Okay. And this operation will be done for every element in the list. Okay, so you can try later. Or we can use the function. Yeah, the NP, they have their own function to deal with this arithmetic. So you can have the NP add, NP subtract, NP negative. Okay, so like this one, -2. Okay, all multiply, divide, floor divide, power, and mod. Okay, so you can use this function. Or yeah, I explain only the first one, the first column. You can try with this one, np.add. So it means, yeah, you will np.add in the bracket 1 plus 1. Or for example, np.add x plus 1. Yeah. Okay, so this is the learning check. Okay. Try by yourself. Okay. So I will not evaluate this result, but maybe on Friday, I will check your course-based quiz. Okay. So if you have very low score on your course-based quiz, then I will call your name, and then I will need you to show the result. Okay. So I will ask you to show the result on the class. Okay, so you can share your screen and then show me whether you already do this one or not. So you don't need to submit this one, but I will call your name, whether you already try with this one or not, especially for you who has the low quiz score. Okay. So try to do the quiz better. So I will not call you. Okay. But if you do the quiz very not good, then yeah, I will call your name always. Okay, I'm sorry because yeah, I think it's good practice for you to understand the content of our class. Okay, please try to understand this one, and yeah, I will call your name for you who have the low quiz score. Any questions? If no question, then I will continue with maybe I still have some time to explain the next section. Yeah, I will just explain a little bit about this one because of the time limitation, but at least you can have some understanding about the Numpy, and we are going to learn about the basic about data in this section. What is the basic of the data? So the data sets are made up of data objects, and the data object represent an entity. If you join the database class, you will see some example like sales database or medical database or university database. Okay? And if it is the database about sales, you will see customer table, or you will see store items, or you will see the sales table. Okay? So those kind of things represented as the object. In university, you can see the entity like students, professors, or courses. Okay? So in every data, yeah, we will do with this kind of table. We will have rows and we have attributes. Rows, yeah, rows, this one is the row. It can be say as object. Or in other literatures, it mentioned as examples. So this is one examples. Or we can say it is instance. So it is one instance. Or data point. Yeah, or yeah, we call it as objects, or we call it as tuples. Okay, so one tuple, the second tuple, and so on. For the column, we can say it is the attributes. Okay. So this is attribute 1, attribute 2, attribute 3. Okay. We call also this as a variable. In one variables, we can have x1, 1, x2, 1, x3, 1. Okay. Or sometimes we call it as columns. So this is a customer data example. If I have the customer ID C01 and the name is Anna and the age is 33, okay, and so on. So we have 3 instances, or we have 3 examples. So we have like 2 kind of data. Okay. The first, the attribute or the dimension or the features or the variables will have a kind of data field. Okay. And this will represent as something we call it as the feature of data object. And the type can be categorical, or continuous or numerical. So we have the ordinal, nominal, and binary. And we have the interval and ratio for the numerical. So what are they? So for categorical variables is just a kind of category. Okay? It takes on small set of possible values, and we have the discrete or qualitative variables. And the information can be sorted into categories. So the category means, yeah, you have the small, medium, large, okay, or you can have the definition about the city, Seoul, Busan, and etc. So there are three types of categorical variables: ordinal, nominal, and binary. So this is the example for the categorical attribute. Okay. Okay, maybe I will continue this explanation on the next class.